everyone, we're going to determine the value of a, or the range of a, at which the quadratic equation will have the given conditions. We have two of them. The first quadratic equation has to have a double root, and the second quadratic equation has to have two different real number solutions. So we want to find the value of a that satisfies both of these quadratic equations. All right, and we're just going to use the discriminant. So basically, we want to have a double root for this one. And all that means is you have some kind of, I'm just going to make something up here, equal to 0. That means it's a double root because you have x minus 3 times x minus 3 equals 0. So it's double here. All right, that just means we have one solution for this one. So basically, we were looking for one intersection point for this. All right, so that's just what that means. All right, so now we're going to use the discriminant for this one. And if you look at this using the discriminant, your a equals 1, your b equals a, and your c is this constant here, a plus 2. So we're setting our discriminant b squared minus 4ac, and it has to equal 0 for the double root. And using substitution, we're going to get b squared, so that means you just square those. That's going to be a squared minus 4. Our a is just 1, we don't need to put that. We have a plus 2 equals 0. So solving for a, we're going to get a squared minus 4a, and then what's this going to be? Minus 8 equals 0. And we can do this completing the square thing. Let's see. We use completing the square. We're going to do a minus, take half of that and square it. And then what you're doing is to do that, we have to add 4 and subtract 4. So to do this, we're going to have a minus 4 minus 8. And I think I need to go over that again. So if you have a squared minus 4a, to make this a perfect square trinomial, we're adding 4 here. And that allowed me to condense this. But since I added a 4 here, I also have to subtract it. All right, and then we have the minus 8. And so that's all I did there. So basically we have a minus 2. This is negative 12, so I'm just going to move it on the right-hand side. It equals 12. Now if I square root both sides, so I square root both sides and do plus and minus, I'm going to get a minus 2 equals plus or minus. Now square root of 12 can be written as 4 times 3. So you can pull out that 2 and then leave the square root of 3, leave the 3 inside the radical. So that means a equals 2 when you add 2 to both sides, plus or minus 2 square root of 3. So that's your a, so you have 2. So a equals 2 plus 2 square root of 3, or a equals 2 minus 2 square root of 3. We're going to be looking at that because this kind of has to match up to this one right here. All right, so now let's do this one. The same thing we're going to do that we did here. We're going to use our discriminant. Now this one has two different real number solutions. So two intersection points. That means we're going to set it greater than 0. So for us, our a equals 1, our b equals 4a, and our c equals 2a minus 1 squared. This is your constant. So we want our b squared minus 4ac to be positive. So when you square this, we're going to get 16a squared minus 4 times 1. We don't need to put that 1, so let's just put the c. And this is going to be 2a minus 1 squared. It has to be positive. All right, so we have 16a squared minus 4. Now let's look at that. This is going to be 4a squared minus 4a plus 1. All right, and when I distribute, I'm going to get 16 a squared minus 16a squared plus 16a minus 4 has to be greater than 0. Well, this just equals 0 there. So we have 16a has to be greater than, I'm going to add 4. So a has to be greater than 4 divided by 16, or a has to be greater than 1/4. Now recall on the other one, what we had is a equals 2 plus 2 square root of 3, or a equals 2 minus 2 square root of 3. It should be 2 square root of 3. So for a to be greater than 1/4, the only one that is greater than 1/4 that holds true, this one's not greater than 1/4. So we have to take that out. The only one that's greater than 1/4 is this one. So this is your value of a. All right? And that's the only one. Anything other, you can't use 1/5 or anything like that. It's just this is the answer. Thank you. Have a nice day. Bye-bye.